Good evening, everybody, and welcome to this Faculty of Science webinar. Just to get to know the Faculty of Science, we'd like to thank you for taking the time to join us this evening. Just to give you a quick overview of what's going to be happening, right after I'm done speaking, we're going to have the Executive Dean for the Faculty of Science, Prof. Moronga, who's going to be giving you a brief introduction. Following Prof. Moronga's remarks, we're going to hand over some time for some presentations that I'll introduce you to the 4 schools and clusters in the Faculty of Science. Following those presentations, we're going to have a very brief question and answer session that will hopefully help answer some of the questions that you might have based on the presentations and also based on questions that you might have about the Faculty of Science. Given that the time is going to be limited, for those questions that we may not be able to answer during the sessions, we will definitely be publishing those answers to those questions in our social media platforms, on all our social media platforms. So you will always have access to get those answers when you need them. For now, I'm going to turn the time over to Prof. Moronga, and then we're going to have our presentations. Thank you.
Good evening and welcome to this webinar organized by the Faculty of Science at Nelson Mandela University. I want to welcome you all, including the parents who are watching. Feel free to write down notes during the presentation so that you can ask questions later. At the Faculty of Science at Nelson Mandela University, we want to produce graduates who are critical thinkers. We want graduates who will be able to solve problems facing South Africa, including the continent Africa itself as well. So we have got cutting edge research. We have got cutting edge learning and teaching facilities. We, however, at the moment are teaching online, but even teaching online, we find that our lecturers, our researchers, they can engage with you so that you feel like you are in the classroom. So please feel free to ask such questions as what will happen in 2022, what programs you can have, and what will it look like in 2022. So don't shy away. Please write down your questions and post them on question and answer screen that you will have. I'm going now to hand over straight to the presentations where you will learn more about our Faculty of Science.
Do you want to know more? Do you want to change the world? In a globalized world that is more and more technological, computing science's knowledge is invaluable. The Department of Computing Sciences at the Nelson Mandela University wants to share their knowledge with you. Knowledge to innovate. Knowledge to develop. Knowledge to create. Through critical, encompassing modern education, we find 21st century solutions to 21st century problems. From bachelor's degrees to master's degrees, and also PhDs, we offer you the opportunity to get knowledge that will help you gain excellent job prospects with top salaries and the opportunity to work anywhere in the world. You also contribute to making a positive impact on society and get to play with cool tech toys while at it. And at the end of your degree, you leave with the knowledge to transform your community. Knowledge to inspire others. And knowledge to change the world. Visit our website at cs.mandela.ac.za for more information.
Good day, I'm Andre Venter, Head of the Physics Department at the Nelson Mandela University. Our department has a rich history and is regarded as one of the leading physics departments in the country, with strong local and international collaborations.
The science faculty strives to educate and develop students of the future. Modern facilities and ultra-modern equipment, combined with the skill and knowledge of highly educated lecturers, create the perfect environment for prospective students to enhance their interest and polish their skills.
Our students, to the best of my knowledge, are very happy with the research studies that they've engaged in, and I'm sure that they appreciate the quality not only of our equipment but also the quality of our training.
The faculty provides interesting studies in a variety of disciplines. To highlight some of the exciting areas, let's look at work within such fields as laser and nanophysics, or perhaps the fascinating world of the electron microscope. Studying materials and specimens at a level of one atom is extremely rewarding and helps to understand how things work, and moreover, how we can apply that knowledge to the development of new inventions.
The physics department at NMU has collaborations with many overseas institutions, from Russia, China, Japan, to Europe, to the United Kingdom, and to the USA. If you study here at NMU, you will be able to work also at the institutions overseas. Nanophysics is a very important field of study. This will enable South Africa to establish high-tech industries, which is essential for economic development.
An additional field of study in the sciences faculty is the area of communications, or more specifically, the field of fiber optic communications.
Essentially, the technology that we research in it enables extremely high-speed internet connections, enabling applications such as streaming voice, streaming video. All of these applications rely on our technology.
This exciting sphere of modern science and communications can lead to very lucrative jobs in the international communications field.
There's an opportunity for our students to visit overseas and spend time overseas. And this exciting opportunity to work with scientists from around the world, learn about different cultures and have different experiences as a scientist and as a person.
Science is an integrated study with various specialties. Although we can research all new fields of development, most will not function without power. And our next area of study involves the field of alternative power, such as solar energy and solar heating.
One needs to look rather at what contribution can solar make, not to replace the existing fossil fuel power stations, but certainly to augment and to contribute to the energy mix.
This specific study researches the use of the sun to provide electricity via solar panels and the development of new equipment and materials within this industry. A further section of study relates to the capturing, concentration, and storage of heat from the sun. With the current global crisis in the energy field, as well as the depletion of fossil fuels, a qualification in this field can lead to international research, as well as development positions at large corporations. Such a vast range of studies in one faculty. Is this the right field of study for you?
I believe that people should study what's interesting to them and what fascinates them, and this is what physics is all about. It's about understanding how the universe works, everything from the smallest atom to the largest galaxy, and to have a job that you enjoy and that brings you satisfaction. This is one of the greatest achievements you can have in life, or one of the greatest paths to follow.
We would love to assist you and trust that you will one day find an academic home in this dynamic department.
Mathematics and applied mathematics is another department in the school. And if we read that quote there from 1989, It says, mathematics is a remarkable sprawling riot of imagination, ranging from pure intellectual curiosity to nuts and bolts utility, and it's all one thing. There's three very interesting diagrams that were all generated by mathematical equations as shown underneath that quote. Give you an example of what you can do and what can be produced using that. The Department of Mathematics and Applied Mathematics consists of two subjects. Mathematics and applied mathematics are separate subjects that you can major in together if you want to. Mathematics typically involves two broad areas, namely analysis and algebra. With analysis, the main topic is calculus, and in algebra, it's linear algebra. And here's an example of a teaching facility, a lecture room where a lecturer is actually, there's the head of the department, Professor Jake Moritz, is giving a lecture on balancing chemical equations using matrix. Pure versus applied curriculum content. The difference between mathematics and applied mathematics is the focus on whether the content is pure, then it will be mathematics, or applied. So the applied mathematics modules focus on mathematical analysis methods, which can be used in a range of science and industrial situations. The first 2 years is mostly maths for application, and that involves calculus and linear algebra. From third years onwards, they begin to encounter proper pure mathematics, where you subjects like the mathematical justification technique from the first 2 years are presented, and also the topic of abstraction in mathematics. Postgraduate studies are offered in mathematics and applied mathematics from honors level up to PhD, and these are on a research basis only, not. The department, here are some pictures from the Department of Mathematics, pictures of students working in labs, students in a lab venue where they're being taught, and a student solving a mathematical problem on a board. Statistics is the last department in the school, and statistics focuses on the study of the methods and the tools used to analyze, present, and model data to make predictions and decisions. And statistics is basically a multidisciplinary subject. So it's become an essential tool for financial analysts, managers, government, business industry, and academics. And there are a number of opportunities to combine a knowledge of statistics in a number of different fields. To become a quantitative analyst, a data scientist, where you actually analyze large amounts of data, a risk analyst, which we have needed in the recent period of COVID-19, in government institutions, and in actuarial science. Now, I've included this quote, which, although it is more than 10 years old, is as valid today as it was 11 years ago. And it's by Hal Varian, who is the chief economist of Google, and he said, the sexy job in the next 10 years will be statistician. I'm not kidding. Just to show you the multidisciplinary approach of statistics, the main focus in the science faculty is integration with physical and computing sciences, but it also integrates with health and medical sciences, particularly in forecasting diseases like listeriosis or diseases like COVID-19, life and environmental sciences, education and research, business and banking, where forecasting is very important, and finally, in government and politics. These are the staff and the students in the Department of Statistics. On the left here is Dr. Warren Brittany. He's the current head of department. And in the center of this group is the previous head of department, Professor Gary Sharp. And you can see some students at the bottom.
Introduce you to the School of Environmental Sciences and take you through a short presentation. The School of Environmental Sciences includes a number of different departments. The departments all having some connection to the environmental sciences. I'll talk about that a bit later. The School of Environmental Sciences is going through a name change and will become, in the science faculty, what we're going to be calling clusters. And the new cluster is going to be called Life, Earth, Environment and Agricultural Sciences, or LIAS. And that hasn't been implemented yet, but we're on the way to doing so. So the question you might all be asking is, why study environmental sciences? Well, it's a simple answer to me. This is our home. You're looking at a picture of our home, planet Earth. As far as we know, it's the only inhabited planet in the universe. It might in fact be the only inhabited planet in the universe that's inhabited by creatures that can think. And it's something that we need to look after, and I'm going to explain a little briefly why that is. This picture is a picture that was taken by the Voyager 1 space probe at a distance of about 6 billion kilometers from the Earth in 1990. And that little dot that you can see on the screen, a little white dot, is what Carl Sagan referred to as the pale blue dot. That is our home, that is Earth, at a distance of 6 billion kilometers from the Earth. That's about 40 times further from the Earth than the Earth is from the Sun. Since then, Voyager has continued its travels, and it is now 150 times further from the Earth than it was in 1990. If you had to travel to where Voyager is at the moment, it would take 37 days traveling at the speed of light. The closest star to us is Proxima Centauri, which is about 4.25 light years away. So at the speed at which Voyager is traveling, it would take 291,508 years to reach the star. So the universe is a huge place, and a lot of people talk about traveling to the stars because the Earth is becoming used up. We are exceeding the capacity of the Earth for all the human activities, and they're talking about going out to the stars, but we're a long way from being able to do that. So let's just have a look at some of the environmental sciences, the departments that are involved: agriculture and game ranch management, Department of Botany, Geosciences, which includes geology and geography, oceanography, which is a postgraduate degree. We don't offer undergraduate degrees at the moment, and the zoology department. If we have a look at each one of these departments a little bit, the agricultural management is a diploma that used to be that is presented in Port Elizabeth and in George, and it deals with livestock, crops, commercial subsistence, farming, and that kind of thing. Game ranch management is a diploma that is now only going to be presented in Port Elizabeth, and obviously deals with the management of game ranches. Then the geosciences, it's a degree program, and you can get the degree in either geography or geology, or a combination of both. And the kinds of things that we do in geosciences are human population studies, which is more on the geography side, remote sensing, which is geography and geology, climatology, integrated environmental management, and resource conservation studies. And we have botany, which is also a degree, and botanists study things like algae, plants, physiology of plants and algae, ecology, conservation, integrated environmental management, and many other different aspects of botany. Then finally, zoology, which is a degree program as well. And in zoology, we're all very familiar with the things that zoologists look at. They look at elephants and whales, smaller things like insects and crabs, but there are a whole lot of other things, much, much more than just elephants, whales, insects, crabs. There are lots and lots of different types of animal. In fact, there are as many, or there are many more species of insect than there are species of plants. Some careers that you can take in the environmental sciences: you can become a teacher, a marine biologist, work on a game farm, manage a game farm, get involved in ecotourism, do integrated environmental management, work in fisheries, conservation, become a nature reserve manager. In the geosciences, you work in mining. So there are a huge number of different fields that you can go into as if you get involved in environmental sciences. But all of them are concerned with our planet and how we should best utilize the resources on our planet so that they are sustainable. At the moment, we really are not behaving in a sustainable manner as far as the planet is concerned. And this is a cause for concern, and it's something that we need to do something about. A lot of people, examples are Elon Musk, Jeff Bezos, Richard Branson, believe that we can leave the Earth and go somewhere else if we completely mess up the planet. So Elon Musk, for example, part of his rationale for going to Mars is that it will be a place that we could go and live in case we completely mess the Earth up. I don't think that we should do that. We should rather look after our planet, because although we might be able to live on Mars, it's not a very pleasant environment in which to live. Then the last department is oceanography, which I said was a postgraduate department because we only teach MSc and PhD level in oceanography. And this is a picture of the Earth, which you don't often see. To make it even more confusing, I turned it upside down. So on the South Pole is in the top, and the North Pole is at the bottom, because it's not really right to think about the Earth being up, down, upside down. Depends on how you want to look at it. And this picture shows North America on the bottom left-hand corner, South America on the top left-hand side, and then this huge mass of water, which is the Pacific Ocean. So a large portion of the Earth's surface is covered by water, and there are lots of things that live in the water. A large component of life on the planet lives in the sea, and the sea, to a large extent, determines how well things work on the land. This is a picture taken from Algoa Bay, looking at the university. There's the main building that you can see on the left-hand side of the picture. These are some dolphins swimming past the coast. This was a picture taken by one of the students doing research in Algoa Bay, and I'll leave it there. Thanks very much for your attention.
Hello everyone, my name is Anton Schmidt and I represent the Natural Resource Science and Management Cluster on the George campus. Today I'm going to take you through a PowerPoint presentation that just briefly gives you an idea of the courses that we offer on the campus. This slide is just to show you what the George campus looks like and where it is situated. The campus is situated about 5 kilometers outside of the town of George in the foothills of the Outeniqua Mountains. And it is surrounded, as you can see, by indigenous forest, pine plantation and agricultural land. It is therefore ideally situated to offer programs in natural resource management. And in fact, we very often walk out of our classrooms and into this open air laboratory to continue our lectures. The 5 programs listed on the slide are offered on the George campus. Firstly, the forestry program looks at the planting, care and harvesting of plantations. Secondly, the wood technology program looks at the preparation and use of timber once it has been harvested from a plantation. The agricultural management program focuses on commercial agriculture and basically looks at the running of a farm as a viable and sustainable business concern. The nature conservation program looks at the conservation, use and management of our wildlife resources. Then finally, the veld fire management program looks at the prevention and control of wildfires. This slide, I would just like to take you through the structure of our programs on the George campus. So typically when you arrive at the George campus, you would normally start by doing a diploma, a 3-year diploma, as is indicated in green in this particular slide. You'll also notice that it is very much practical and career orientated. And 1 year is actually a practical year where you do work integrated learning, which means you go out into industry and in a structured way you get training. And then your other 2 years are academic work that you do actually on campus. So in this slide, it's also indicated that your practical year is the 2nd year of study. This is not always the case. It differs from one diploma to the next. For example, in our forestry diploma, the 2nd year is in fact the practical year, but in our conservation program, the 3rd year is your practical year. And in the agricultural program, the practical year is straddled between your 2nd year and your 3rd year. Nevertheless, you end up with a 3-year diploma, of which 1 year is practical year and 2 are academic. Then, once you have completed a diploma, which is a qualification on its own, you can then go and do an advanced diploma. And this just offers you an opportunity to specialize in the particular field that you've chosen. Following an advanced diploma, then, if you are research orientated and would like a career as a scientist perhaps, then you could consider doing an honours year. So that's also a standalone qualification, and we will be offering an honours in natural resource management. And this essentially in this year, it prepares you for a research career. So once you've completed an honours, you can then also carry on studying and do an MSc and then eventually a PhD. Now, typically, both our MSc and PhD qualifications are research projects that you would go out and do, and you would have to show that you can do original research and that you can carry it out and analyze your results, properly, as a scientist would. And typically, an MSc and PhD would take you 2 to 3 years, respectively, to complete. Okay, in this slide, you'll see that I've marked the certificate in veld fire management separate from our other qualifications that I've just discussed. And this is because the certificate in veld fire management is a year qualification that anybody who's completed a diploma or an advanced diploma or even an honours, any of those qualifications on the left, could then go and do the certificate in veld fire management as a completely standalone add-on to his previous qualification. And if you are planning a career in natural resource management, whether it's as a forester or a farmer or a nature conservationist, a certificate in felt fire management is really an excellent add-on to have, because controlling wildfires is an important part of any natural resource manager's job. This slide is just to give you an idea of our learning and teaching philosophy in the Natural Resource Science and Management cluster. We believe that to run any enterprise based on natural resources, you need to take care of your environment, your business, and your people. And so, in other words, the type of student that we would like to produce would be a student who eventually has a very strong environmental ethic, a student who's an entrepreneur, and a student who, once he is qualified and working, is able to make decisions in a complex environment. We also want our students, once they get their first qualification, their diploma, to be ready for the workplace. And we really feel that the year of practical experience that they get in their diploma helps them really integrate their theoretical knowledge with the experience that they gain when they're out in the workplace. And this really prepares them well, helps them to hit the ground running when they start working. If you want to go on and develop a research career for yourself, then typically you would do postgraduate studies on campus, and this means that you would do an honors and perhaps eventually a master's and a doctoral degree. So all these degrees are research orientated and involve doing a research project. On campus, we have two specialized research units that you could do your research projects under, although it's not necessary that you do it with them, but it certainly helps. One gets a lot of expert guidance within these units in terms of research. So the first unit that we've got is the Sustainability Research Unit, and they've actually also, how shall we say, host an international research laboratory on campus that we refer to as REHABS, which is short for Reconciling Ecological and Human Adaptations for Biosphere Sustainability. And this international research laboratory is actually a French research laboratory. It's the French CSIR, and they have these, what they call research laboratories, scattered all over the world, of which there are only 2 in Africa, and 1 is actually on our campus. So one gets really good international guidance if one works within one of these units, if you are going to carry on and do further research. So if you are keen on natural resource management and a career in this particular line, then you would be welcome, and you would like to do one of our programs on the George campus, then you could contact our admissions office. So that is, on the slide is their email address, george.admissions@mandela.ac.za. Okay, so this is all I have for you for today, and thank you for taking the time to listen to my presentation, and we really look forward to seeing you on the George campus. I'm now going to hand you back to my colleagues in the science faculty. Once again, thank you very much.
Good evening, everybody. My name is Zani Chentu, and I'm the director of the School of Biomolecular and Chemical Sciences in the Faculty of Science at Nelson Mandela University. I just want to discuss a bit about what we do in our school. Our school, of course, has a Department of Biochemistry and Microbiology, Chemistry, and Human Physiology. But Before we go into each of those departments, perhaps let's look at the qualification papers for a degree and diploma, because our school covers both. When we talk about a bachelor's degree, we talk about a broad knowledge base. The focus is more on the theory and methodology of disciplines rather than specific skills in that discipline. And so it prepares one really for a postgraduate study and for general employment rather than for a specific field of work, while the diploma focuses on specific knowledge. So one has to demonstrate particular skills that are required in that field. And so it would even have a work-integrated learning component so that one can acquire those workplace skills that are required. Okay, let's look at the Department of Biochemistry and Microbiology. When you talk biochemistry, I mean, think about biological molecules that are at work every microsecond in our body. Think in terms of enzymes and proteins that carry out a lot of biochemical reactions in our bodies. And when you think in terms of microbiology, think in terms of viruses, your bacteria and fungi, and how those affect humans, animals, and plants, and also their ability to make physical and chemical changes in our environment. You would remember that we're engaged with coronavirus currently, and so think in those terms when you think microbiology. Okay, of course, biochemistry starts in second year because you need a bit of foundation of chemistry 1 and a bit of mathematics, physics, botany, zoology, and then you engage with biochemistry. And then from there, you can move into the postgrad degrees. When it comes to research in the department, they're involved in diabetes, cancer, HIV, and other areas. Microbiology also starts in the second year. You need a bit of foundation from other subjects before you engage with microbiology 2 and then into third year, followed by postgrad programs. And in terms of research, then mostly engaged in medical microbiology and industrial microbiology. Think in terms of making cheese. It's an industrial process. Okay, careers in biochemistry and micro, of course, in medical research. They're involved in agriculture, food industries, I just mentioned cheese, pharmaceutical industries, biotech industries, etc. And when it comes to the Department of Human Physiology, think beyond just chemical processes that take place in the body, but also the mechanical processes. So physiologists engage in both in order to understand responses in health and diseases. They also start in second year when it comes to BSc physiology major. You go through second year, then third year, and then go into honors and then postgrad programs. And research areas in those postgrad programs, also cardiovascular systems and HIV, they are engaged in. Several others that are listed here, your endocrine disorders, and also recently also neuroscience. The fields where they engage in, obviously also medical science field they engage, as well as forensic. Think of it that chemists can only go a long way to analyze your inorganic and organic matter. When it comes to biological samples, then physiologists fit right in to engage with those types of samples. And of course, in medical engineering as well, they would be engaged in there. Chemistry, of course, it's quite a broad department at NMU. It's quite comprehensive. It covers the diplomas and the degree. When it comes to the degree, you can move on, of course, from the degree to honors and then masters and PhD. From the diplomas, you have to go to the advanced diploma before you can go into honors in chemistry. But we also have another specialized honors in formulation science. People who are making products, be it your household cleaning products or formulating even drugs, all sorts of things that require a formulation of some sort. And with analytical chemistry, in terms of the diploma, the focus is on the skills required for analytical chemistry, less on the fundamentals of chemistry, in terms of organic, inorganic, and physical. And you can see a whole range of skills, of careers that are possible with analytical chemistry. In fact, every country needs it, because the food that we eat needs to be tested. The drugs that we take need to be tested. So customs is very important to check things that come in, and forensics, we need to engage analysts there. I think in terms of the wine exports in Austria, that fell drastically once ethylene glycol was discovered in their wines by analysts in Germany. And so that industry took a knocking in the short term because of that. So it's very important to have our food tested. When it comes to polymer technology, focuses on paint, rubber, and plastics at NMU. And you can see a whole range of companies that employ our graduates, from Blascon, Continental, Bridgestone, Goodyear, etc., etc. And they will be engaged in formulating products then, such as when you make car tires or molding plastic products and formulating paint products, etc. When it comes to chemical process technology, the focus again is on controlling the process. So one is to understand process equipment, process chemistry, the operations, the controls, because you don't see what is happening behind the reactors. So you can only control via a computer. So even though we train students how to simulate control of processes and how to add things into reactors and control temperature, pressure, etc. But we also have a mini plant where they can actually go in and have a bit of a practice. And typical industries are your oil industries, your mineral industries, fine chemicals, and household products. There's a lot of research that's going on in many fields of chemistry. Rubber is quite key. We have a Center for Rubber Science and Technology. There are other fields like biotechnology, where we use algae to products, and many other fields as listed here. And we also have a research chair in chemistry, which is engaged in using micro reaction technology to make drugs and important chemicals, which could be important for South Africa going forward, because we import a lot of chemicals and drugs. Websites here that might be important as you engage with NMU. Thank you.
Greetings, Nelson Mandela University prospective students. I am Astandile Nzondwa and I'm currently pursuing my honours degree in botany. I completed my undergraduate degree in environmental sciences right here at the Nelson Mandela University. The time I've spent here has been delightful, sometimes challenging, but delightful overall. I've had the opportunity to meet some of the most amazing people, that being my lecturers and my friends, of course. The science faculty provides an interactive learning experience both on and offline. When I tell you that the lecturers are amazing, I'm not lying. You just need to be willing to learn and be open with interacting with them. If you do that, then you will definitely enjoy your time here learning about physics, chemistry, zoology, or any other science you're interested in. Besides having lecturers passionate about student success, you will get the chance to interact with senior students, like myself, who are always willing to guide you through the university experience in and outside of lecture rooms. And if this hasn't convinced you to join the science family yet, then the Nelson Mandela University provides fun student activities such as societies, sports, and other extracurricular activities such as the Madiba's Radio and the Beyond the Classroom program. I've had the pleasure of being an executive member of the Science Society, and it has been a great experience to communicate with people with similar interests as I am, and people who come from different cultural backgrounds and share different perspectives on life. Plus, joining societies also helps boost your CV. So I really hope to see you all in the near future as graduates of the Nelson Mandela University Science faculty. Thank you.
Thank you so much. And now we're going to have just a brief question and answer section where we will give you an opportunity to ask any questions that you might have based on the presentations that you've seen, or based on the any questions that you might have coming into the Faculty of Science. One of the first questions that we often get for students that are interested in a science or scientific-based program is, how do I qualify for a qualification in science? So, as you've heard, we offer in the Faculty of Science, we offer degree qualifications and we also offer diploma qualifications. And what's important is for you to have an understanding of your AS score, or your applicant score, that is the total of your percentage that you receive with your matric qualification. And for a BSc qualification, the minimum requirement is that you have an AS score of at least 410, and you have at least mathematics as one of your subjects. The only qualifications in science that don't necessarily require you to have mathematics are those in the environmental science diplomas, where you can come in with technical maths, with maths literacy, and also with maths. And your AS score is calculated whether based on which one of those that you do. I'm going to turn some time over to our directors just to give them an opportunity to talk a little bit more about the qualifications that they represent, specifically their areas of expertise. I'm going to start with Dr. Anton Schmidt to speak a little bit about, maybe just give a minute or two to speak about the qualifications, well, his area of expertise in the at the George campus. Dr. Schmidt.
Thank you. Thanks very much, Yvonne. Yeah, I think what I didn't maybe mention in my presentation, and perhaps I should have, was sort of where our students typically in the different programs that we offer, where they get employment. And so if I were to start off with the forestry program, foresters leaving our institution would get employment. Mostly, I think most of them get employment with the big private forestry businesses such as SAPI and Mondi, although some of them also work for municipalities and obviously for the government. With agriculture, most of our agricultural students are employed on private farms, I would say, and businesses. The wood technology program, it's almost a follow-on from forestry. They are mainly employed in sawmills that produce timber for industry, for construction and that sort of thing, roof trusses, etc. And then our conservation students, they would typically go and manage game farms or private nature reserves. And some of you who are keen conservationists might even have seen the program Wild Earth on Mnet, and a few of our past students are actually present on that program. Steve Falconbridge, you might know him, and Dylan Smith in the Kalahari. So that kind of job in the eco-tourist market is also available to students qualifying on our campus. So that's in short, I think, the different programs that we offer and what opportunities exist if you do one of these qualifications. So Yvonne, I hope that helps.
Thank you very much, Dr. Schmidt. I'm going to turn some time over to Prof. Brenda Scholz, who is representing the School of Computing Sciences and specifically the Department of Computing Sciences.
Hi, good evening, everybody. So in our school, the different disciplines work very well together, particularly in light of the new demand for data science skills and data analytics. So we have computing sciences, which is computer science and information systems, and as well as statistics, maths, and physics. So a combination of these subjects leads to a very good qualification, which is high in demand in industry, and typically graduates can work in a number of industries, consulting industries. They can work as programmers, physicists. There's a large demand for these skills. We actually do not have enough graduates to actually satisfy the need of companies. And I must say it's a good problem to have, but we are constantly inundated with requests from companies. We have some large companies even in Gqeberha, but countrywide and internationally where these students can be placed. Thank you. Or graduates rather. Thank you.
Thank you so much, Prof. Scholz. We're going to go to Prof. Chentu, who represents the School of I always get this wrong, but Biochemical Sciences. And of course, as mentioned, some of our names are changing. And so we are wanting to actually streamline our program so that they fall within clusters. And clusters will make it a lot easier for students to actually decide what field of study that they want to go into. But over to you, Prof. Chentu.
Thanks, Yvonne. Well, currently it's the School of Biomolecular and Chemical Sciences, but soon we will move into a biosciences cluster, which will have biochemistry, microbiology, and physiology, while then the chemistry will be in the physical sciences cluster. So obviously our students, even within the biosciences, your biochemistry and micro, as we interact currently, some of our postgrads and even undergrad students are engaged even at Aspen as we speak, who are producing the virus, the vaccine. So they are well prepared for that kind of environment. And within the chemical sciences, as I said previously, it's quite spread out in terms of weight and gauges. I mean, for example, polymer technology, we don't produce enough polymer technologists. But industry needs them. So the rubber industry, the paint and the plastics industry needs these graduates, but we can only handle few at a time, obviously because of the nature of the work that they've got to engage to prepare them to engage there. Maybe what I can just add is the requirements to get into those diplomas, because you've covered the degrees. But as far as chemistry within those degrees, if you cover chemistry with biochemistry micro, then the 60% mathematics is fine. But if you move with chemistry into the physical, mathematical, and computing sciences streams, then you need at least a 65% there for mathematics. While in these diplomas, you need 55 for mathematics and 50 for physical science, in addition to the applicant score of about 350. So I thought I would touch on that because the requirements, the entry requirements differ for the diplomas. You also need the physical science to get in with at least 50% physical science, while maths would be a 55. Thanks, Chair.
Thank you, Prof. Chentu. I'm going to turn the time over to Dr. Dupree from Environmental Sciences. Dr. Dupree?
Thanks, Yvonne. One of the things I always like is when people ask me to say a few words about something that would take years and years and years to explain, So I'm just going to say a few words about what I'm interested in. And one of the things that I'm interested in is improving crop production. But the problem with improving crop production is it's normally a very negative process because you have to use more land, and the application of fertilizers to soils damages the soils and so on. So it's very difficult to improve crop production without doing damage to the environment. So it's a good idea to try and find ways to manipulate plants so that they're more productive and giving us the kinds of things we want without damaging the environment. And one of the things that we've been doing recently, I'm not talking about me myself, but scientists in general, is to manipulate plants so that they take on some of the special characteristics of things like cyanobacteria, because cyanobacteria have really fancy mechanisms for increasing the carbon dioxide concentration around the enzymes that are responsible for fixing carbon dioxide. And this is a very, very active field at the moment. Mechanisms of making plants more productive without having to go into new areas of land. So increasing plant productivity on land that's already being farmed. Another thing that's very important to me and I'm very passionate about is that we have to look after our environment. I mentioned it during the introduction to the school. The environment's in serious trouble and we need to understand it better so that we can look after it better. What do we have to ensure that we conserve and look after so that the world can continue to function properly? And one of the big things that we've discovered is that we have to look after the oceans. The oceans play an incredibly important role in maintaining the climate of the Earth, in making sure that processes take place that take carbon dioxide out of the atmosphere, because the increasing CO2 concentration in the atmosphere is what's causing global warming. So there are organisms that live in the sea that do that for us, but we are damaging the marine environment to such an extent that the ocean isn't working properly anymore the way it should. And we've got to reverse those processes so that we can improve the way in which the marine systems function to do what they've been doing for billions of years. And I think I'll hand back to you, Yvonne, otherwise I'll keep going all night.
Thank you so much, Dr. Dupree. As you can see, everybody, science is broad. And something which I really love that was mentioned earlier is that, you know, the best way to choose what you're going to study, if you're going to choose a program in science, is to follow your passion. As Dr. Dupree has shown, that when you have a passion for something, it actually helps drive and motivate what you're able to accomplish. Now, tonight, we haven't been able to answer all of the questions that we received, but as I said earlier, we will be publishing answers to all of the frequently asked questions relating to joining the Faculty of Science on all of our social media platforms. Please take the opportunity to visit the Nelson Mandela website and also all of the Nelson Mandela and the Faculty of Science social platforms that you may be able to find out more information. The more informed you are, the better prepared you are. Again, we want to say thank you so much for taking the time to join us this evening and participating with us, and hopefully that we've given you something to look forward to, or maybe something to look into a little bit more. And we look forward to welcoming you in the Faculty of Science in 2022. Thank you again for your time this evening.